Building retuning training was conducted by Ron Underhill and Gupong Liu, scientists at the Pacific Northwest National Laboratory. Classroom and on-site training for Maryland State Agency facility managers was conducted at Towson University in Towson, Maryland on June 17th through the 19th, 2014. This segment of training covers fan-powered box terminal units.
So we have a series link fan power box and also the parallel fan power box. So for the series fan power box, they have to run continuously and interlock with the primary L. And right-hand side is the parallel fan power box. So they only need to run during heating seasons. So actually, this is very efficient of that parallel fan power box. So the left-hand side, the series fan power box, they requires less of the pressure before the terminal box. So this one is a very good opportunity to do the reset of the static pressure set point. So the benefits of retuning the fan power box, that includes we can reduce the fan power consumption or the terminal fan power consumption, and also minimize the simultaneous heating and cooling, and also reduce the complaints from occupancy about the terminal fans noise, and also reduce the maintenance cost. The key condition we want to look at the charts is the fan power box terminal fan condition. And also we want to see if there's a lot of the terminal box damper position, also the reheat valve position. Unoccupied setback schedule. So we want to determine see if the fan power box fan schedule interlocked with the L handler fan schedule or not. Like the series fan power box, we want the fan schedule for all the terminal box interlock with the primary fan. So if the L handler is shut off, we want all the terminal fans shut off. Some place we run into is terminal fans runs 24/7. They don't have any schedule for that. So each fan may be quarter horsepower to half horsepower or 3/4, right? So if we add all those terminal fan together, it can be a big number. Some places they have like hundreds of fan power box. That means there can be 75 horsepower for some buildings. So we want to review the plot of fan power box fan status versus time to see if that's scheduled for all those terminal fan. Another thing we want to look at is the reheat valve for the fan power box. So we want to determine if the minimum airflow set point is too high or not. So just like we discussed for the normal terminal box, the retuning measure, the recommendation for the fan power box we want to recommend is to define and enable unoccupied setback if possible, and also interlock the terminal fans with L handler control. Reduce box primary minimum airflow based on the ventilation requirements. Especially the second one, it's very important, especially for those parallel fan power box, because we know that those fan power box, you only need those fan running at heating season. So one of control measure you can do is to, if the ambient temperature is higher than certain, let's say 65 degrees, 70 degrees, you can disable all the terminal fans. In that way, you can prevent the fan running during the summertime. The benefits of doing the fan power box retuning, we can minimize the simultaneous heat and cooling, and also reduce the fan power box terminal fan consumption, and also improve the thermal comfort and reduce the noise level.
I also want to talk about these terminal boxes. Now, a couple of things that we really didn't highlight is if you can see my mouse up on the screen, this area right here shows basically where a filter would go. That's a filter rack. And you see it again right here on the right side, both the parallel box on the right side, the series on the left. Those filters are out of sight, out of mind. You guys are all, if you've got fan-powered boxes, you guys are all doing maintenance, right? Not me. Somebody's going after, somebody's looking at them. Somebody's looking at them, I hope. Because, again, if we've got issues with filters plugging up, pretty soon the airflow delivery to the spaces is challenged. The coils that are downstream, and both of these could have, and they show heating coils. If those start plugging up, now we're challenging our terminal box and its airflow delivery capability and its heat transfer capability. And so those are things that we want to pay attention to from an O&M standpoint. You know, do we go out? Again, we're throwing a lot of things at you. We've talked about sensors. Are we calibrating them? Are we validating their location? Filters, coils. Here's more filters and more coils. We think of filters on a rooftop unit, packaged unit, or an air handling unit. But by golly, now the vendor, the engineer, he put in filters on all these packaged terminal boxes. So those are things to be aware of. Another thing to be aware of on the series, which is on your left side on the screen, those are fan-powered boxes. They always run all the time. They should run whenever the primary fan's running. At night, I don't need to turn my fan on for heating the space up. I can just let these cool down to their individual settings, whether it's 60 degrees, 65. They've got a fan. They're designed, by design, they are configured to move air from the space and recirculate and move it across that heating coil. I don't need my primary fan. In fact, for a warm-up, I don't even need my primary fan for a warm-up. And I'll guarantee you what we've seen on a lot of fan-powered systems that are series designed, like what you see right here. I get colder air from the primary fan because it's bringing in minimum outdoor air. It has no heating coil or it's not sized properly. And so now I'm actually cooling the air that's coming right here to the series box is colder than what's in the space, and I'm challenging my warm-up period. So something to think about. It takes more code, but maybe I could do a warm-up for wintertime, maybe cold shoulder months, without running the primary fan, save that horsepower, and just use these to spot heat. But again, once you get to your cooling mode, then these have to run in tandem with the primary fan. So it's just something to think about. A lot of options. Static pressures, yes, go ahead.
Do you want to talk anything about the neutral, they get the adjusting the fan properly, that the tab should adjust the fan properly so that the filter is sort of neutral, it's not sucking, it's not.
You're talking about the filter on these boxes?
So that the pressure at the filter is neutral, so it's not sucking more from the plenum, more from,
yeah.
So that the tab guy,
yeah.
or gal, has to make sure they're set up properly.
Yes. And I'm not going to talk in detail except to say this. They're doing a one-time setup configuration based on some known condition, filter and coil. So we know over time that's not a static, that's dynamic. It's going to change over time. I don't know that anyone's going back and readjusting. So I'm struggling with the value of that. I know why they do it, but again, I'm struggling with how we do O&M in our facilities going to that level of effort. Static pressure, I think we said this earlier, but on the series fans, if you go to the vendor websites, most of them will tell you they require about 1/2 inch to 3/4 of an inch at the fan from the primary fan right here, because they've got these big fan motors that are sized to move the air. From this point, they're just taking the tempered air from the primary fan and moving it down the ductwork. And they are, you'll see we said constant volume. So it's kind of a misnomer. Everyone says, oh, it's a VAV system. So what's varying on these types of boxes is their constant volume to the space. They're varying the amount of air they're taking from the primary fan. These are true VAV to the space. And they will require more static pressure from the primary fan to operate properly.